Hey everybody, this is Brad Dyke saying hi to you. Ran into a couple of hiccups. So I thought they would be good hiccups to show everybody what I had encountered as I was working with my Gen 9 HPe DL-380 chassis. And as you know, this has been kind of a running project for a few months. I've been kind of very cherry picking the parts and the pieces that I want in it. So with that being said, let me show you what I'm talking about. So as you remember, this is the DL-380 here, and it's a much more evolved piece of hardware opposed to what it once was. And it has the bay assemblies which I put in. I've got the extra space for future design. I've got the media bay insert, and I've got future growth here as well. And of course, I'm still ordering parts and pieces to bring certain items online. Let me take the cover off here. So as you can see here, I'm taking the cover off now. And I may have gotten a little excited. And as you can see, I've got two 8 gig sticks in here to balance over across two processor stacks. These are the 2680 series. These are high-end processors, and I have transitioned the interfaces, the sinks, and everything from the original large block sinks to the smaller ones like I did in the video. And I have, of course, exchanged the plastic guard, which is a very important item. But I may have gotten a little excited. Maybe too excited. What do I mean by that? Well, I'll show you. Just because something can doesn't mean necessarily that it should. If that makes sense. And so sometimes we tend to quickly get excited and we put baseline cards into the system that probably need to be vetted. But I was excited and I wanted to get things done and kind of skip a couple of steps, which normally I tell you not to do, but if you've done it 4, 5, or 6, or 7 times, inevitably you can do that from point to point. And as you can see, I am removing what I think is the problem. I'm just going to get him out. Doesn't want to. And there it is. An NVMe card. PCI Class E Type 2. Decent little card, but it does tend to generate some grief out there. And this guy is sizable. Should be 512 gigs. So what I should have done is I should have gone back to the basics, which I do recommend, by the way. And by doing that, you are able to do, confirm that your hardware is functional. And so because I didn't do that, that's bad on me. And of course, I hit a hiccup in the process. Now, something else you'll discover with these units is they're very track-fed dependent, so you have to get them just right. So if they don't go in right, they just don't work. There you go. Now you can lock it down and consider it locked. Now I also have over here on this side also a similar configuration. These are the multi 10 gig interfaces, and I'm going to take those offline as well, including the HP quad card, because I was looking at the strategy here to do a couple of things, but I decided not to do it this way. As you can see right there, there's the quad card, and then of course here is the 10 gig NIC. And this is an open Gbit configuration, so you can pull that guy out, and there's your 10 gigger. They can do copper, they can do direct connect, or they can do fiber. And now I have a basic clean configuration here. Now I am going to add one thing to this that I finally got and took forever to get. And I'll show it to you in a second here. Let me first get the alignments correct. Again, got to align it to make sure it works. And then only then will it work. So these are good. So let me go ahead and put this special cable in. If you look at it, it is a power and a SATA bridge cable. One part of it goes over onto the base of the interface card set itself, which is right here. You've got to get in the right location, of course. And then it is to travel underneath the fan base, which of course, whenever it's out of alignment, tends to stick on you. Come on. There it goes. And this cable will gently go in to its own hiding spot to provide connectivity for the CD-ROM disk. And I do have a need for the CD-ROM, so I have it there, and I do want to use it in the future. Once that is in play, and as you can see here, I still have an open charge bay here as well, if I want to. I could also choose, if I wanted to, and reroute this actually across like this on the cable route. The only challenge with this is when you stick it over here, it does get a little cramped when it comes to putting in the fan array. We'll try it though. It does work both ways. Okay, so that is now in play. And so this is technically a textbook deployment. It's got HP hard drives in it. It's got HP CD-ROM DVD drive. The USB bus is operational. There's no other configuration on there. There is no SD card. There's no USB inboard or outboard interface. It is just basically a core CPU RAM only device. And all the peripheries I took out of it. My LS card, my LSI SAS card, my NVMe card, quad card, 10 gig card. I pulled all those out to make sure that none of them were going to create a conflict, which I do suspect they are, on the PCI configuration setup config file, which is not a happy critter this time. So now what I'm going to do is I'm going to go ahead and do this to go back to home and go onto the KVM network and be able to get this staged. Now give me just a second here. Okay, so we've got this now posting. As we can see here, of course you can't read that, but we're looking at a post configuration boot set. Now what does that mean basically? In a nutshell, that means that it's got to clear some of its configurations. But this seems to be where it sticks. So we're going to let this run for a minute or two to see if it unsticks. I'm going to initiate F9, and it is working, which tells me that we have a legacy interface problem with one of the PCI cards. Now, what I mean by a legacy problem, and this is very common when you buy old stuff and you mix it with newer stuff and you're trying to create something new in concept. So with that, I'm going to go in here and see, okay, what's going on. First, I want to check the health of this system. I want to see if our environment is good, that our buses are good, the NICs are good, the ILO is alright. I don't usually use ILO. And of course, configuration for the health status of the RAID controller configuration tool. So the HPe SSA. So we're allowing it to go into diagnostic mode and to check the PROM on the actual RAID controller, and of course the bus interface bridge cards that I put on hand that I can use to work with what I've got. This is bringing up the Smart Storage Administrator tool, which is pretty cool. It's kind of like Curmudgeon. The BIOSes are building their own little tiny containers to do things. And then, of course, once it's all good to go, it should post into its instance. Now, this is something that a lot of you guys have brought to my attention, is the BIOS integration opposed to the sub-BIOS integration versus the BIOS container integrations, and so on and so on, and how much of a potential pain that can be. Are there ways around it? Yes, there is. The key thing to do first is to make sure that you get past the initial configuration of these files first. Once you can get past them, then you can get into the post-boot state, which is where you would find your other BIOS devices, like an LSA HPA controller interface, or a Mega RAID controller card, or an Adaptec card, or a Dell PERC RAID controller, or an HPA controller, so on and so on. So the secret sauce here is to develop this in such a way so that we're going to be able to get past the baseline configurations, keep them baselined. That's the secret sauce right there. Don't develop them. Let these machines take these resources and put them off to the sideline. They'll continue to work for you and do everything you want. But the real work that you want to do is past that, especially when you're dealing with legacy interfaces like old legacy cards and so on and so on. So you just saw here on the screen, and if you look here real closely, I'll bring it in closer for you. You see something what we used to see a lot of in the configurations of Windows and Linux environments. But what they've done is they've used a variation of maybe a Docker / commigration strategy to subline these protocols in these CMOS graphic user interfaces like you see here. This is a graphical user interface. And then they bed it into the BIOS level. There is no operating system here. It doesn't exist. There's no hard drives. There's nothing. No SSD drives. There's no USB drives. There's no SD cards. This is all firmware and RAM resourcing and RAM drives and so on and so on. So with that being seen here, and as you can see this, I can now go in here and start working with this Smart Array P440 RA platform and to start to configure it out. Stand by here for a minute while I set the two principal disks into a RAID 1 configuration. Into a RAID 1 configuration with a hot swap. First, I want to check the health of the state of the drives. There they are. I have 1, 2, 3, and 4 512 drives. I will have 3 of them in a RAID 5 configuration and 1 in a hot swap state. Then I have a 1 terabyte which I'll treat as a playground only. I could add a second 2 terabyte drive, but I don't want to at this point, for this is the test system. So we know that we have no alerts on these, and we are reading them correctly. They are coming up correctly on the CL. Smart is not running correctly on this because these are SSD drives, and Smart Protocol doesn't work very well on those. So what I'm going to do now is I'm getting a critical notification here that the P44AR embedded slot has unsupported configurations and may not support the function of this controller. What are they saying? Well, you don't have HP hard drives inside an HP chassis. That's what they're saying. So with all of that being identified, you can go ahead and qualify that and recognize it and then retire the message, and then it will go away. So what I do then, now I had to give it a little bit of time, so I paused the video there a little bit to get you to the place where you need to be. But now I'm at the point where I'm going to configure this out, and I've picked 3 drives that I want to have in play, and that will give me 1 terabyte of capacity for the boot operating system. And I'm going to do 256 stripe K write cycles with full stripe sets. That's going to really create a fast write cycling because we can do it now with SSDs. Size allocation, you could spoof that down. I wouldn't. Just partition your attributes so you can take full advantage of them. Parity initiation, go with defaults. SSD over provisioning optimization, to a degree, but as far as I'm concerned, this is a tricky thing. Over provisioning means to possibly crash the SSD array. Now, I would suggest that you do not perform over provisioning optimization and just leave it as is. Now it can explain to you what it's talking about. It says when enabled, the array SSD drives will be prepared before the logical drive is created. Please note that this option may make this operating task longer in completion and could possibly cause SSD striping. Now, SSD striping basically means that you could corrupt the actual RAID configuration. SSD drives do not do well at all if you fully optimize their capacity. In other words, you fill them full. If you fill them full, they can't do what they do well. So always remember to keep 18 to 20% of the drive clear at all times to get maximum effect. So with that being done, we're going to go ahead and set these in play. And we're going to create the array. That is fine, because these are SSD drives. Okay, so we have use capacity in play. We have the storage capacity availability. It is building. Available allocation out of the 1.45 terabyte combination, I have 953 gigs of availability. That's 3 stripe 512 gig drives in parity set. And at this point stage, I will finish this. Now I want to add one spare. And I'm doing that now, and I'm adding that spare dedicated to the designation of the 512s. And now we are complete. So let's take a real quick jump over here. Again, we're back on the main screen here, as you can see. And over here, the array has gone from a prepared state to a configuration state. Now, this guy's got my attention a little bit. Now, these are the 3 on the RAID 5 pairing with the hot swap. This is a boot drive, so the performance is not a big issue. This, on the other hand, that's got my attention. Something's not quite right there, so I'll have to figure that out. So taking this back to our work, now we're going to allocate the 2 terabyte drive as a standalone RAID 0 drive. And we will get to that. I'm going to create. We'll select one target. Again, this is the 2 terabyte drive. Write cycle will be 256 by 256. That will be fine. Sector interleaves will be 32. We won't change that. We have 1.9 terabyte of allocated unprovisional and non-redundant storage capacity. And we're going to not allow optimization of over-provisioning, because we will never push a single hard drive that hard. That's an SSD drive. Allocation is built and it is complete. Now, with that being the case, I can now install a baseline operating system on this environment. Now, the baseline that I want to install tentatively is going to be Mint Linux. The reason why is because Mint Linux, which is this guy right here, this USB stick, has the ability to do some special functionalities Ubuntu-wise that I want to take advantage of, but I do like the Mint distro, if you want to call it correctly, as the proper format. Now, before I can take advantage of this, though, I do have to do a couple more things here. I need to look at the cache manager to see how we are doing on the cache manager, and I want to make sure that I understand how much is available within limitations. So I have 2 gigs of allocated cache memory, and it is functional and allowable. It is not being blocked by lost power because of a failing battery, which is very common with RAID controllers. You need to make sure that you check this. So what will end up happening is if you do have a degraded battery on a RAID controller like this Smart Array P440 AR, you can force the RAID controller to work in a poor state or in a diminished or degraded state. And it will tell you, I'm running in diminished state, please be advised. Now, with this being the case, everything else seems to be pretty solid. Licenses are in play. Encryption is inactive. I don't want to use encryption. Okay, so we are good. So I'm going to go ahead and exit the application and allow this environment to go ahead and repost. I'm going to get the USB stick, as you can see here, prepped on the chassis. Okay, and now with that being the case, while we're waiting for the process to clear itself, and we're going to initiate a reboot. So while we're waiting for the reboot to kick off, let me ask this question from you guys. I've got this dead space right here, and I haven't decided. I don't think I will put more discs in here, because that's not my goal this time. I was thinking about putting something else in here that I can act as an air block, because I want the airflow to go through the right places to keep everything going. But I haven't decided what would fit well in this hole. So I could do another media bay and have it like these multi-inserts in here and put it in here. Or maybe I can do something else if you guys have some ideas. Let me know what you think, and we'll take it from there. Now we're coming back up on the post. As you can see, everything on the baseline is being ran. I do have an ILO that is configured, so I have to be very careful about that guy. I need to neutralize that ILO. It is not in use, and it has no value to me at this point stage. There's also IP version 6 emulation running. That's got to be crippled as well. Don't leave protocols running on your server if you're not using them. So I've been trying to figure out what exactly does this cover do. Nothing. It doesn't balance airflow because it's got gaping holes on the top and the bottom and on the sides. Not sure what exactly it's supposed to do. You know what I mean? So here we are in the actual BIOS boot process, and it is starting to load. We are going to hit F11 to initiate a build configuration. Now, this system may or may not actually... No, I take that back. Let's reboot. Hang on a second. The reason why we have to reboot is because the last thing you need to do is go back into the BIOS configuration menu and bring up the BIOS to confirm you're either in UEFI boot mode or BIOS boot mode. Very important detail, by the way. This is such an interesting... I understand now why some of you have mentioned some of the griefs with the Gen 9 series about all the preloads and the postload configurations that kick off. It definitely looks like HPE is putting their own inline tools and resources ahead of your environment, consuming your resources before you even get off the table. Cannot neutralize that, cannot neutralize that, can't turn that off. You could limit these a little bit. The PCI initiation, that's required. The ILOs you can get rid of. You can shut those down. You can trim this down, but I don't use HP's solution that HP wants me to use. The reason why is because it's all geared to making a profit for HP. So let's give this a couple of, about 3 minutes here real quick, and I'll be right back. I'm going to put this on pause while we wait for the screen to refresh. Okay, now we're at the system configuration setup. And we need to do this first because it's very important to identify the boot mode. In the old days, we would just run everything in BIOS mode, but that doesn't work. So I'm going to go into the BIOS mode here, and we're going to look at the boot options. And we need to confirm, okay, it is set up to UEFI. Optimized set value and portal attributes are in check. Boot maintenance is available. System configuration, serial port configurations, USB. Let me check these guys real quick. Never hurts to walk through these to make sure they're fully optimized. A lot of times they'll screw with the USB ports and port console interfaces. You want to make sure that you are turning that off and getting the devices back in service again. Yes, it is very important to restrict them in an operations environment. It is not necessary at all to do that with a environment itself. Now, other things that you find that tend to be modified here and tend to throw you off is the fact that in virtualization, they may have these disabled because they're using it as a telecom server. You know, it's a singleized task, high availability kind of setup. These are working correctly. The boot time optimization is set to auto, which is fine. Memory optimization is set for ECC mode, which is good. It can be more complicated. You can do mirror ECC if you want. I don't recommend that. Go to your network configurations. Now in here you can turn some things off. You don't necessarily need to have any of these ports for networking wise because of the fact that they are going to take up time on your environment. Now you also have here the ability to kind of pseudo control the DHCP services emulation. You can avoid that for now. You don't have to play with that. Check your pre-boots to make sure they are cleared. Make sure you have no predefined values. Okay, they are not there. DHCP is running and is running in mode. Emulation iSCSI is turned off. VLAN configurations are not required. Storage configuration, FCOE, which is fine. You can do that. You know, run it by target mode only. That's probably the better approach than to use OpenScan, because FCOE can do that and it also makes you vulnerable. So that's something you have to be very careful about. Now, you also want to identify your boot policy sets for storage capacities. It does identify my embedded RAID 1 controller interface, the P440AR controller, with all targets selected. The UCLE and the UEFI shell command is enabled, which is fine. It's kind of a pain in the butt. Power profiling is based on balanced mode. That's fine. Performance is set to enable with turbo boost and encode support. You can go in and optimize your processing stacks. I do not recommend this. They're actually pretty tweaked out already, and servers aren't designed to really do that. They're designed to last you a long time and take a terrible beating in the process. Security should be in the clear. It is. PCI device enable. All device buses are enabled and they are set to PCIe standard. Availability is set to defaults. By serial console interface is VTL1. Server asset information disabled. Advanced ROM CCLs are in the clear. Yep. Date and time, it's good to confirm. Today is not, it's not midnight. It is, has to be corrected. It is, right, right. Get your time zone correct. What the heck? Oh, there it is. Okay, got that set. My time was off. Go ahead and turn on that godforsaken thing. And time format is consistent. So, and of course you've got the values that which you don't want to have. Alright, now the unit is set value and it is ready to boot. So I'm going to pause the video here until it does its process. and when it does the process, it will be finished. And matter of fact, wait a minute, 1 minute before I do that, I want to take a look at the ILO, and I want to cripple the ILO. So there it is. Off, neutralized, advanced de-adaptive, gateway disable, pathway non-specified, and disable routing, and disable yes, and as well, and yes as well. And if you see a reference to a domain ID name or something like that, just put something in like test.local or something odd. Don't do something definitive or well known like google.local or something like that. That can be determined. ILO is great and ILO is bad. You have to go in and you need to take actions and to purge attributes to make sure that you're dealing with the system and that these are not easily identifiable, specifically passwording it. And by doing it that way, you are crippling any and all backdoors. That's very important. Don't make that mistake of not doing that. And when you get the option to do things like remove rights and just remove those functions ILO wise, do it. In my suggestion, you should definitely do that. This is what we call overhead. When you get old equipment from eBay, the initiate process of this is that you have to go in and find these backdoors. That's a very important detail. Once you've got these guys set and they're secured, then they purge their values out and they're no longer functional, which is a good thing. Unfortunately, because ILO is what ILO is, it tends to get into your system and wreaks havoc with it until it's totally turned off. But, okay, we are good now. And I'm still going to go in and make sure, because I've got the option to do this, I am going to cripple these services for the ILO, because I really don't want somebody coming into my environment and using ILO to bypass my environment. And with that being the case, I am now heading out of the configuration so that I can reboot the system. Now we can get the game going on board, but before I do that, let's do one last system check. The DL-380 Gen 9 Series 2 Set 4.1 is valid. The processors are the 2680 series version 4s, 2.4 gigahertz. Lots and lots and lots and lots of processors are built onto that. The ILO is reporting as crippled, and the network ports are in open standby. So we are good. Now we can reboot the system. And here we go. Okay, so now we have the system now booting into a state for configuration and usage. Now, the key thing about configuration and usage is the nature of the interface base it's working with. Now, that means basically, in a nutshell, for you and me, I've got this paired all the way down to the most basic standards for it to work. Now I am using SSD drives, but nothing else here. All the other peripheries I had in, they're all still missing. They're not in the chassis, and I'll still have to go through one or two of those going in at a time so that I can get my 10 gigabit bandwidth for the backbone work and so on and so on. So right now, though, I do want to set the OS up initially to stress out the instance environment of this chassis to really make it work hard and make it earn its pay. This chassis is one of the more detailed chassis I've done. I pretty much have rebuilt it from the ground up. Even the motherboards are not the same original designs. I really specialized this process in the clear so that we can do this. So we're waiting now for the boot menu screen to come up on the SSD drive and see if we'll get a post. Well, it looks like we've hit a bit of a snag here, and I'm going to have to research this more, see what's going on. We're not getting the initiate for the CLI command line to start in any form of boot up that's available. So that's interesting, odd, and yet kind of a spin to the left versus spin to the right. What I might do is I can put in a DVD drive and try to force it into a DVD boot, but I'm going to go do some research first on this to make sure it's going to be okay. It's okay to get to a point where if you need to stop, you need to stop. Do your R&D on this to figure out something's odd going on here, because you could have a glitch, you could have a firmware problem, you could have a few other things that are happening. And I've gotten past 7 different levels already, so I'm pleased with what I've got. But the boot menu, which is the 8th level, which is the status configuration for an operating system installation, was my next goal. And unfortunately, to my surprise, it's not posting anything when it comes to a boot post mode. So I'll figure out what's going on with that. Why is it a blank screen? Could there be a VGA controller interface issue? It could be a couple of possibilities. And if so, then I have to spin to the left and turn to the right and, readjust and to get the system up and running once again. Well, this is Brad Dyke signing off. I'm going to let you go. God bless and have a great week. There's more to come. There'll be a part 2 as I get to that point. Take care, guys. Bye-bye.